Okay, so the next part here we're looking at is 4.1b. So this is kind of an extension on section 4.1. And we're just going to look at when you're expanding the binomials, there's what kind of pattern do we see? And this will save you a lot of time if you recognize this pattern, and sometimes you don't have to use the whole FOIL step right away. You can kind of skip a few steps. There's two parts to this section. I won't go over all these questions because it's going to take me a while and it's going to get kind of boring. Maybe I'll fill out the first sheet and then the second sheet we'll go through a couple random ones and we'll look at what observations we have. So making my own notes, I guess you could kind of do this out yourself as well, but or you can follow along. Okay, so choose your own unique, not the same as your peers, values, and there are natural numbers to complete the space below. So natural numbers, just choose like whole numbers that above 0, so 1, 2, 3, 4, 5, 6, etc. So let's just choose here 3 and 4. Again, you could choose other numbers. And let's expand it out. So expanding it out, remember FOIL. So first terms, outside terms, inside terms, and then last terms, right? So watch the previous video if that's confusing. But when you FOIL it out, this is what you'll get. Okay. All right, and then finally simplify. This is expanded form when it's just out, and the simplified form is when you collect like terms, so the middle terms here. Okay, there we go. And let's do another one. So let's do 2 and 6. Yeah, and let's expand it out. So 6 times x, then x and x times x squared. 2 times x is 2x. 2 times 6 is 12, and that's what you get here. Okay. And expanded form, collect like terms. Okay. And finally, let's choose 5 and 9, for example. So x times x, x squared, x times 9, 9x, x times 5, 5x, and 9 times 4, 45. Collect like terms, 14x plus 45. Okay, so what kind of pattern do we see here? Rule, when multiplying two binomials and two positive, uh, wait, when multiplying two binomials with two positives, there you go, the result is x squared plus bx plus c, where b, so when they're saying in this kind of format, b is the middle term here, right? And then c is the last term here. So b here, you can see this value, b is all positive, right? So positive. And c is also positive. So that's something to note. So when the binomial are both positive, the middle term here will be positive, and then the last term will be positive. So there we go. So um, okay, let's just do this in next example. So let's choose 2 and 8, and you have two binomials that are both negative here. And let's expand it out. So x times negative 8 is, oh, actually let's do the first term first. X times x is x squared. Negative 8 times x is negative 8x, and then negative 2 times x is negative 2x. Negative 8 times negative 2 is positive 16. That's expanded form, and then put it together to get the simplified form, negative 10x plus 16. And let's choose two more, so negative 4, negative 1. So x times x, again, x squared. Then it's going to be negative 4x, and I got negative x, positive 4, collect like terms, negative 5x plus 4, and finally, let's do negative 6 and negative 3, so x times x, x squared again, x times negative 3 is negative 3x, you got negative 6x, and you got 6, 12, 18 plus 18, okay, and collect like terms, negative x plus 18. Okay, so what do we notice here? Okay, what's the pattern here? So when multiplying two binomials with two negatives, so both binomials have the negatives, the result is positive bx plus c, where b is, so what is b? B is always going to be negative, and c is always going to be positive. Another pattern that we see here. Okay, finally, this one, we're going to do a few of them. There's more examples here because this is not going to be straight, either negative and positive, positive, negative. This one's a little bit different. So let's just put some numbers. So positive 7, negative 2. This one could be positive 3, -5, and -4, or +4, -2. Okay, we'll do one more, I guess. So -10 and 1. And we'll think that'll be enough for this. So multiplying it out, and I'll try writing this pretty quick. By now, I think you guys got the hang of this. Okay. And this one here, x squared -5x plus 3x minus 15, x squared minus 2x minus 15. We got x squared minus 2x plus 4x minus 8. And then you got x squared plus 2x minus 8. And finally, x times x squared, -10x. You got plus x and plus minus 10 actually. Okay, so we got x squared minus 9x minus 10. Okay, so there we go. So we got enough examples to see the pattern here. So you can see the first term b is positive, negative, positive, negative. So the b is changing. The last term is always negative. C is always negative. So we know that C is always negative, right? C is always negative last term when you have a positive and a negative binomial. And then B can be either positive or negative. Okay, so here you can see B is always changing. So B depends. So if this value is, the positive value is higher, then B is going to be positive. Or if the negative value is higher here, for example, then B is going to be negative, right? So there we go, the rules. Two positive binomials, B and C are positive. Two negative binomials, B is going to be negative and C is going to be positive. And if one is positive, one is negative, it depends for B. Sometimes B is positive, sometimes it's negative, and C is negative. Okay. For each, from each of your examples on this page, what can you conclude about the numerical value of B? So you can see that B, it'll come from adding these two values together. So you see plus 2x is basically just putting the two values here together. So it comes from adding the two numbers in the binomial. Okay, and what about C? So what about the numerical value C? So you can see here, you're just multiplying the two values together. So -10 times 1, -10, 4 times -2, -8, right? So C, it comes from multiplying the two binomials. Okay, so these patterns, obviously you don't have to technically remember them. You can just always just FOIL it out and you'll still get the right answer. But if you remember these patterns of OB just comes by adding them together, C comes from multiplying them together, and then you know how to check your work. Okay, if it's two negative binomials, I know that B is going to be negative, C is going to be positive, and if it's not, you made a mistake. This will just save you time and allow you to check your work and be a little bit faster, right? So that's 4.1b. The next section here, okay, let's put this to the side. Let's take a look at this. Okay, so I'm not going to complete all of these questions like I said before, but I'll go over like the important ones. But here's a general rule. So remember you got binomial times binomial. And remember, this is, if you FOIL it out, you'll get the expanded form. And remember the B term is basically just the two numbers in the binomial added together. And then the C term is just the two numbers multiplied together. It gives you the C term, right? And then you get a trinomial simplified. Okay, so pretty much all these questions, you're just doing that. Nothing tricky. Maybe I'll do the harder one, 6, which it's not too hard. All you do here, so if you have a number outside of the binomials, multiply them first and then have the two afterwards. So for example, Here, I'm just gonna put it to the side, and now I'm just gonna FOIL it out. So p times p is p squared, right? And you know the trick. You're just adding the two middle numbers for the b term, which is 9 plus 8 is 17, and you put the p here. That's what we're doing. And the last term here is just multiplying it. So 8 times 9 is 72, right? So that's how you can do it quickly without having to FOIL it out. And now we're just going to multiply the 2 inside to each of these terms. So it's going to be 2p squared plus 34p plus 144. Yeah, easy. And hopefully you can read that. Looking ahead, so this section, there's going to be a little tricks, I guess, when you're looking at like special binomials. So when you say special binomials, like what happens if is there like a pattern when you multiply a binomial by itself, by another binomial? Right, so we do that a few times, right, here as well. And what happens when you multiply a binomial with its like opposite? So the negative here. So you could do a few of these to find the pattern, but I'll do a couple, then and you just have to, I guess you trust me. So we'll just do an opposite, and then we'll do one that's the same. So here, we'll do a couple then. So if you FOIL this out, so you get x times x is x squared, and you know the middle term b is going to be the two terms added together. So 4 and -4 is 0, so it's gone. And the last term is just the multiplied together, which is -16, right? So we'll do one more. So again, y times y, always start with y squared. The middle term is them added together, which is 0, -10 and +10. And the end term is the multiplied together, which is -100. Okay, so you can see the pattern right here, and I'll write it down formally. But if you're multiplying the opposite binomials, the middle term is gone, and the last term is just going to be the square, the negative square of the number. Okay. Now let's just look at the positive one before I write the rule. So, or the one binomial multiplying it by itself, the exact same. So here we got x squared, and then 8 plus 8 is 16, right? And then we got 8 times 8 is 64. Okay, so let's do one more. So y squared, 5 times 5 is 25, and then we got oh, sorry, you're supposed to add them together. So y squared. Middle term is always added. 5 plus 5 is 10. And then, and I didn't write the x here. Okay. And then 5 times 5 is 25. Okay. So I kind of took a long time doing that, so I'll do one more. So p squared, so middle term of them added together, which is -18, so -18p, right? The middle term has the one variable, and -9 times -9 is +81. Okay, there we go. So what kind of pattern do we see here for when it's the same binomial? So you can kind of see if they're the same, the middle value is just the double, right? Because we're just adding itself or subtracting itself. And then the last term is just the square. Okay. So let's just write the rules here. So let me just move this up. If the binomials are the same, double either number for the middle term, right? And then the last term is the square of the number. And square number. You can see, for example, middle term is just it doubled. The last term is just itself squared. Okay. And then what about the opposite case we looked at earlier? If the binomials are opposite, okay, there is no middle term, right? So let me just finish writing this down. There is no middle term. There we go. So they're opposite binomials. First term is squared, middle term is missing, and the last term is just the negative square, I guess. So there you go. Same thing here. Middle term missing, negative square, last term. Okay, so that's chapter 4.0, 4.1, a little bit extra on 4.1. And yeah, now we'll move on to sections 4.2 and 4.3 next.